All right, derivation of the equations of motion at constant acceleration. Equation number 4. Lights are waning, so let's get this done. All right, number 4 says that velocity squared equals velocity original squared plus 2 multiplied by acceleration and displacement. So here we go. What we're going to do is some pure algebraic substitutions. So here we go. From equation number 1, we got v equals v naught plus at. Equation number 2, d equals v plus v naught divided by 2 times t, the average of these two velocities times t. So what our strategy is going to be is to solve each equation for t and set them equal to each other. Okay, so I got us started here a little bit. Let's check it out. All right, so Phineas, excuse me. Don't want to tip you over here. Thank you. All right, you hold on. There we go. Got two equations. V equals v naught plus at. D equals v plus v naught divided by 2 times t. All right. Well, we're solving for t. All right, so I'm going to subtract both sides by v naught and then divide by a, like that. And that equals t. Beautiful thing. Over here, in order to solve for t, I'm going to multiply by 2 and divide by v plus v naught. All right, so t here equals 2d divided by v plus v naught, like that. Okay, so now I'm going to set them equal to each other, okay? So I have v minus v naught divided by a equals 2d over v plus v naught. Okay, what I'm going to do is multiply both sides by v plus v naught to get that over here in this numerator, and multiply both sides by a to get it over here in this numerator. So what we then have is v minus v naught times v plus v naught equals 2ad. The 2ad is good. This is a good sign because that is a term that's in the fourth equation. All right, so I think we're on the right track here. Well, what we have is in parentheses we have variables here that need to be multiplied out. So we use FOIL or something like that. Can't remember how they describe it to you in algebra, but basically we multiply each term, and so we do the outsides first. V times v naught. So we have v times v naught insides, negative v naught times v minus v naught times v. All right, and what we've got is the firsts. FOIL, something like that. V times v plus, okay, v squared. That's the first over here. I should have done that first probably. And negative v naught plus v naught is negative v naught squared equals 2ad. All right. Well, now what we're going to do is kind of combine all the like terms. All right, so here we go. V times v naught minus v naught times v. Well, these are the same because we can switch these around in terms of multiplication. They're the same value except one is negative. So these guys cancel each other out. Hey, so what we have is kind of some nice looking stuff here. V squared minus v naught squared. So that's v squared minus v naught squared equals 2ad. That's almost there because our original equation was in terms of v naught. So in terms of v. So let's solve for it. So we have v squared equals v naught squared plus 2ad. Hallelujah, we got it. All right, just took some algebraic manipulation on this crazy board, solving for t first, then setting them equal to each other because the t's are equal, and distributing out foiling out the variables in parentheses, and come across this. Fortunately, these guys cancel. That's very convenient, leaving us with v squared minus v naught squared equals 2ad. Solve for v squared. We got equation number 4 in the books. There are the 4 equations of motion with constant acceleration, all derived for you. Now we get to use them. Bonus, Morad, out.